Welcome everybody to our second foundation category. It is actually the third episode because we did our architecture 101 and 102. You'll find them on the YouTube page. Today we're moving on to the next part of the foundation series, which is to look at the overall recommended ecosystem workflows, how you can work from business hypothesis, the business layer to get value, implementing and choosing different options within the platform, getting to your deployments and monitoring everything that comes after that. So today we've got Jay, who's going to be running the session for us, and Bodhi that's going to be co-running. We'll be looking at one of our murals. I will be sharing a link to the mural, so you guys will be able to view it as well. There will be a visitor link in the chat.
Thanks, Jess. I suppose I should share my screen so that we can all see, or unless Jay, maybe you want to share, or whatever will be easiest.
I think, Bodhi, you share so you can guide us
Okay,
forward.
yeah.
What we figured we'll do today is have an interactive session where Bodhi will work through the storyline and we will create some key questions that we know normally get asked and give some answers to those as we get through the detail. So what might be useful for everybody, because this is a tech series, if you post your questions in the messages, or if you just raise your hand, we will make sure that we get to those as we go through the various steps. The big purpose of this particular session is that there are many different practices, processes, software engineering capabilities, data science sequences, and various approaches that you can follow to get to an end game. We would share with you some blueprints and some of the key decision points that need to be in place for you to get to a successful predictive outcome. And if that predictive is for static models, dynamic models, or generative models, there are a number of steps and actions that are really good practice to implement. And we'll be working through those. So Bodhi will be guiding it, and then we'll be getting into the detail as we go through that. Okay, Bodhi?
Perfect. Thanks, Jay. Yeah, just to highlight another thing before we get started, I feel like this mural and hopefully the session overall is also going to point out where ecosystem fits in a broader setting of an enterprise ML workflow. That's often something that comes up in conversations with customers, clients, prospective customers, and prospective clients. It's difficult to explain where one fits in the long value chain of an ML workflow. So this hopefully is going to be a combination of, just some of our experience and generalities of what an ML workflow should look like and where the technology that we provide and specialize in fits in. The core place to start is going to be at a more of a meta level than specifically a technological level, and that's what we have labeled here as a kind of business or more meta layer. To define your prediction story is where we recommend you start your ML flow. So that's going to fit in with respect to the business problem that you're addressing, right? So you're going to hopefully have some like specific purpose or specific goal that you're trying to reach, and you're going to want to be quite clear in regards to perhaps your like machine learning canvas as to how you're going to achieve this. That's going to involve choosing what features you're going to predict and why. This is normally coming from a business point of view, so it's more likely this sort of decision gets handed down to the technical people who are going to be deciding and actioning on it. For example, we can see some of our graphics here, predict X from Y to enable impact on risk, on finance, or reduce risk, or increase customer engagement. So those sort of relationships in your ideal chain of causality is something you're going to want to outline before you start actually implementing anything on a technological level. You can always refer back to your ultimate goal and make sure whatever models you're training, whatever methods you're using, ultimately align with that. So I think
what might be worthwhile mentioning is that if an organization is using agile methods, and they have epics and user stories, if you look at most of the user stories that are created, they've got to do with user interactions and the like, and they're not well equipped to define what a prediction concept is going to be delivering for you in the context of the user story. So what we've done previously is we map a prediction story to a user story and then use the canvas to have a disciplined approach to describe the outcomes of that particular prediction story would be that's going to give business benefit. So maybe just a point of reference for everybody that's involved in the agile space.
Thanks. The ML canvas is always an interesting thing to talk about because it's something we kind of lord over a lot, and we really recommend that clients and customers engage with the method. It has many different sections, and it has a whole little history here you can read the blurb on if you're interested in. But yeah, there's three core phases: the learn, predict, and evaluate, right? And then there's going to be several different components to that, mostly concerned in the customer engagement dimension. That's where we map the prediction story to the user story. There's going to be like important things that you may not think about, like your behavioral approach, like what is some of the non like computational, but rather like social behavioral methods that are going to like motivate your solutions to this given business problem that you've identified. Yeah, I mean, Jay, maybe you want to speak more in depth on the use of the ML canvas specifically. How does that work in an actual enterprise setting? Or is it something that business people would just use in outlining their own ideas? How does this actually translate on a technical level to like employing any specific machine learning solution?
I think that in an enterprise setting, it often starts with the concept of the use case. The use case is, and how that relates to a particular problem that you're trying to solve in an enterprise setting. The use case normally is something that would deliver some output, some value, and that you would need data as input, predictive capabilities, integration with existing technologies, track its performance over time, understand what the value is to the organization, depending on its purpose. So there are many moving parts that you would then need to go and consider when you want to define what the enterprise value is that you're going to derive from any kind of predictive capability. And I think that what ends up happening is that you have two avenues. You have one avenue where predictive capability could be novel. There was no need prior to ChatGPT or generative linguistic chat models for people to have conversations with chatbots that are going to lie about everything but feel highly enlightened because they get something that sounds like it's human. Somebody invented something and then made it available. The other avenue that is far more applicable in an enterprise setting is when you know what kind of product you sell, who you sell it to. You know what it takes your organization to deliver on that outcome. So you know what efficiency looks like. You have a far more deliberate design and intent in mind. If you want to influence making more money, saving money, or protecting money, and you want to be able to define what the business value is that you're going to derive from any predictive environment, you want to be able to have a method. And in that method, you want a template to consistently guide you in getting to an answer. The machine learning canvas, the AI canvas, even GPT or the value proposition canvas or the machine learning canvas for the use case designer that's currently publicly available, they assist you in figuring out what the value is that you're expecting to derive from this use case. So if the value is economical or efficiency, making something quicker and faster, or to detect anomalies or fraud, you want to still have an understanding of that. Once you have an understanding of that, you want to know that you have access to the evidence that's going to help you decide what the future looks like. How will I predict an outcome? If I predict the outcome, where will it be used? Number one on this canvas is understanding the value. Number two is that can I use behavioral and advanced techniques? And number two on the top right is, can I use the data that I have collected in the enterprise? And if there's no data, what algorithm do I need to apply to still get my use case implemented so that when I get to number three, I know exactly where it will be used? So is the prediction used in, let's say, a chatbot? Is it used on my website? Is it used to tell an employee what to do next? Is it got to do with flagging something and automatically stopping a transaction, guiding a transaction? What is the real role that it's going to play. Because if you have a value proposition that is, I want to predict when a customer comes to my business what product they're going to buy next, and I want to nudge them to make sure they buy it. You want to be able to figure out that the data that you're collecting is about that person's channel journey. They have signed onto the web, they looked at some products. By the time they looked at the third product, or they have got items in the inbox, I want to message them or create a banner on top of the site to nudge them to say, if you buy right now, we give you an additional 5%, because you are predicting that they might leave that transaction and not make it happen. Number 3 is, where does it get embedded? How does it actually get used? And then 4 and 5 are mostly used by your technical team. What kind of questions do you need to ask your tech team for them to be able to get to an answer for you to get your prediction to work? Number 6 is, can I track the performance of this prediction? So can I track, if the use case was built on the basis that I am going to make more money if I do the following recommendations, how do I know that I'm actually doing that? And that's what number 6 is. Can I monitor? Can I track? And can I then create some kind of link that gives me the causal link between the real impact measure of what I'm achieving over time? So can I see the link between the action and the response? And is it giving me what I'm... So that's why I believe that in an enterprise setting, this is quite important, because it might end up in a business document or business definition requirement, or it might end up in some kind of value definition that goes to a board for approval. It could end up in many situations, but you have a framework that helps you with all the elements. So that's kind of what I often see in corporates. It definitely creates a very complete view of what is needed for you to get a prediction implemented.
Yeah. Thank you. Great analysis there of the use of ML Canvas. I know personally, just from working with the technologies, one of the most important things to keep in mind is that laser focus on the goal you have in mind and the actual objective in terms of how whatever use case you're designing or building is generating business value. We can move now to the practical side. Once you have done that theoretical, conceptual, foundational work, that's when we can move to the more practical implementation. This is where we're going to start moving closer to the fun part. Often when I'm working with prospective clients or even people within the team, there's huge excitement to get to the building or training of the model and like defining the hyperparameters, etc. Because that's where all the excitement is. But like personally, and as Jay outlined, there's real importance in that conceptual work first. But yeah, so the project details is something we talk about. It's a great place to start with your use case. It's when you're going to want to translate some of those points that you've made in terms of linking the causal link between the action and the value. How are you going to translate that into an actual plan and actual specifications for a use case within Ecosystem's product? As you can see, we just have some screen grabs here, in dark mode, defining all those necessary things. Once project details have been outlined, that's when you can move to building out the actual workers within, specifically in regards to your models and your deployments that are actually going to be live. We talk about 2 different ways of engaging with the ecosystem, with Ecosystem's prediction platform, where all this building is going to take place. So that's the workbench, which is our web GUI, and the Python notebooks. Any Python environment that has access to the APIs hosted by the containers, you can also work there. For more visual sake, the workbench is also a nice place to be. So once you have outlined your project, then you're going to want to like create and define those specifications within one of these 2 interfaces. Yeah, and then once you have your project outline defined, we're going to move down to away from the like business layer to the ecosystem technology. So before we go further into speaking about the specific tech, it's important to have a good idea of what is at your disposal. What tools do you have to execute on this value proposition or ML Canvas plan you've created? At Ecosystem, we talk about our ecosystem of technologies that we offer. Here, you can see we're talking about the dashboard as a visual, low, no-code environment. Several pieces of technology fit together to provide the necessary environment for the development of the solution. So, for example, we can talk about the Jupyter notebooks, which come ingratiated into the platform itself. So there is a built-in Python environment that just works out the box that comes with the platform itself. So this is a great place if you're starting with your exploratory data analysis, right? It's quick and easy Python to visualize data depending on where your instance is set up. Then there's a list of those technologies that we use to meet certain points. In the ML Canvas, for example, we use primarily the Grafana and Superset dashboards. These are two great open source tools for evaluating, in terms of that evaluation step of ensuring that the solutions you've crafted are closely linked to generating the value you're aiming for.
In our world, because everything is headless, what does that mean? That means that all the core algorithms and capabilities generate data points and produce outputs that are not really visible to anybody unless you make them visible. So if you want to make it visible on a dashboard, and let's say that you use Microsoft's Power BI or any other dashboarding tool that you are comfortable with, you need to gain access to a data source where the results were stored. So we are big fans of open source products and technologies that run in the browser mostly. So you'll see that Superset was created by Airbnb initially, and it's a global open source project that essentially allows you to do all kinds of dashboarding without having to run any installation on a computer. So you can run a back-end server that does all the work for you. In the ecosystem technology stack, we have a native deployment of the Superset environment so that people can browse any of the results. We publish pre-designed dashboards that are available open source that people can extend. And Grafana, it's probably one of the world's most well-known real-time dashboarding tools, often used for hardware and networking. We use it for real-time scoring because it was designed to really focus on real-time data point monitoring. We provide a connector to the Grafana environment where you connect to our server, and it will collect the data from any scoring runtime to present you results in real time. Even though these are two options we talk about, any front-end dashboarding tool can be used. We are fans of these products because they are open source, they scale incredibly well, they're completely integrated, they can be deployed across multiple platforms, so this makes it accessible. And I think maybe this worth, I just wanted to make
no, definitely.
And
I mean, to expand on what you said, I mean, in regards to the headlessness of our architecture, that stems from the fact that all the outputs are exposed via the server APIs. The most important thing is that all the outputs that you're generating are machine readable for any other piece of technology you would be interested in funneling them into. As is the case with any sort of dashboarding software, you can just point it to the ecosystem logging and then define some queries from the logs. And then in that way, you can have real-time dashboarding, right? It's because of that machine readable output at all points across the platform. So then there's the Swagger, which is just the web UI defining and explaining all the available APIs offered by the runtime and the server. And then here we just have a bunch of stickies thrown against the wall in terms of other technologies that we've seen integrated into an ecosystem like workflow, right? So H2O, for example, is a machine learning framework that is used in the ecosystem backend. Jay, maybe you want to comment on like the level of PyTorch and TensorFlow and AutoML integration of an ecosystem deployment, because I feel like that's also key.
I think that the approach that you would want to follow if it comes to generic algorithms, and what are those? So if you use something like a gradient boosting machine, a distributed random forest, an XGBoost, K-means, T-SNE, or a generic deep learning neural net, or whatever that might be, it's no point building an algorithm with an entire stack from the ground up. You want to pick the technology that's the most appropriate for that algorithm to run, so that the value you derive from a platform like ecosystem is the fact that we manage the hyperparameters and the configuration of everything abstractly. And you can easily migrate your prediction definition from one model of training to another. So if you look at TensorFlow first, TensorFlow is owned by Google. It is used across a multitude of different environments. It's a deep learning environment. If you want to train deep learning models, there's an entire TensorFlow model training framework, and there's an inference framework to score against the model. PyTorch is built by, or initially built by Meta or Facebook at the time, and is by far the world's most popular deep learning generic framework. So even companies like OpenAI or any of the companies that provide generative models have trained their generative models using PyTorch. It comes with a full framework that you can deploy on environments like Ray. Ray is essentially a framework that gets deployed across multiple GPU clusters for you to train, especially models that are incredibly large. Both those support deep learning related models mostly. H2O was designed to be a high-speed inference engine that deal with classical machine learning as well as deep learning algorithms. So it was built from the ground up to do incredibly fast inference. And that is what we are really interested in, is that can we score, let's say, a very deep tree or a complex tree using a boosting algorithm, like a gradient boosting machine, and get to a score within 1 millisecond, especially when we deploy it at scale. And that's what H2O allows us to do. So it was designed to be this incredibly scalable, very algorithm diverse, open source framework. All of these frameworks are open source. So for companies to make sense of all the capabilities that exist within these environments are just too complicated. So we specialize in that. We abstract the complexity that you can define a hyperparameter in the ecosystem environment, train a model, put it into production, score against it, and do it entirely without having to write any code if you want to use our no-code environment. If you want to use our Python libraries, all of the work that normally goes into getting the pipeline to work are already done for you. So that just means that it makes it easier for you to have a consistent, reliable process to get it into production. And then AutoML as an open approach to how models are used to select which models are the best. There are many implementations of AutoML. So if you run in a cloud environment like SageMaker, or you go to Azure Machine Learning, or you go to Vertex at Google, or whatever that might be that is within your focus, they all offer variations of these algorithms. For us, we don't compete with these companies at all. So if you trained a model in your cloud environment that's going to score, let's say, against a tree method to get a response as an output, you want to be able to get that response and embedded within the overriding flow that deals with the logging, scoring, and the agentic framework that already is part of our capability. AutoML is when you have an algorithm that decides which algorithm is the best to select based on the conditions presented by the data you are using. So we use AutoML quite extensively. We have auto pipelines for AutoML and the like. So if you think about something like data drift or model drift, that is often a challenge in many companies, is that it'll automatically detect if the model parameters are wrong and assist you to fix it, especially if you're folding the model or you're dealing with validation criteria in your AutoML algorithm. So it is a mechanism that you can use every day when you retrain your models to solve your data and model drift problems that normally would have required additional data science time and initial calculation time. You want to remove that complexity. We believe that if you bring all of these pieces together, you need a company or a framework like the ecosystem environment that can have a worker architecture where you don't have to worry about the technicalities of H2O having done an upgrade or PyTorch added new functionality. We deal with all of those challenges. You just have to make sure that you keep the ecosystem server running and you are in the go. So in a nutshell, Bodhi, I think maybe that's enough for this exercise.
Yeah, no, I think that was a perfect breakdown of the public tools that we use. Even the other day, I was in conversation with a prospective client, a bank, and yeah, in conversation with them, they explained to us how they were looking at H2O, and we had to introduce the conversation of how H2O isn't the same class of product, right? We're completely integrated with H2O. We love H2O, but it's not going to solve your problems the way you may think it is.
H2O is a lot of tools that are incredibly good at automatic feature engineering. We almost always recommend for clients to look at that anyway. But when you start looking at the rate of learning and how, let's say that if you look at our dynamic approach for real-time convergence, and you then think about, the way that models will converge based on human interactions in real time, that's not something that happens automatically. You need a special class of algorithm that is definitely not supported by H2O or TensorFlow or PyTorch. So the idea is that you deal with a custom implementation of some of these algorithms, or do you want somebody that can abstract your hyperparameter definitions away from the technical complexities. So it's not like we at any point in any of our cycles would recommend H2O, PyTorch, TensorFlow. Clients can use all of those because they probably will end up using those if they want to do a lot of the work themselves. Then they will realize over time that the amount of work that goes into maintaining those and dealing with it long term is typically far greater than the benefit they're going to get of just using a worker architecture will be utilized depending on the use case.
Yeah, exactly. And then deployment is also the natural next step to talk about in that world. It is one thing to use these powerful open source tools to train some model, and then you have this .mojo file. How do you implement these predictions practically onto a customer base of 40 million people? That's a different conversation. And that's when other aspects of the product architecture become way more important. But yeah.
One thing that's worth mentioning is that if you think of something like ML Flow, I mean, we always recommend these kind of tools anyway. So if you use your cloud pipelining or other environments to deal with all of your generic historical, and especially if you have, models that you've trained that are outside of your competitiveness space, you want to be able to automate it, like 99 or 100%. You don't want to have humans intervene. It's too costly. So that means ML Flow and a bunch of other tools probably can be added to this list. But on our developer site, people can go and see that all of those are described there.
I think it'll be cool to touch on the more traditional public tools that are available, but there are also several more proprietary tools in our repertoire that we haven't touched on yet. So for example, there's several algorithms that ecosystem has developed like in response to specific customer demand. So that includes the entire like spend personality segmentation framework and the client pulse reliability, like etc. Again, as Jay said, you'll find more exhaustive lists on our developer site. And as you also touched on, the whole online learning class of problems. And then we institute several semi-proprietary custom algorithms there that are highly effective in that space. Ecosystem rewards, this is one example. We have those are also pieces of technology that deserve mention. The list goes on. So we can talk about the permanently in production architecture, etc., etc. I think it'll be important to move on to the decision-making process of instituting like these tools. So what to use when to solve our problem, right? So the natural place to start is data management. We can ask ourselves a few questions. If we generalize it, it would be like, do we have sufficient data to train a model to meet our prediction story in some way? Yes or no? There are options obviously in both categories. So and again, that is in reality a more nuanced question to answer, but let's assume for now that we're following down yes, and we have some big volume of customer data and we want to predict some customer feature from it. So then we move on. How are we going to institute this data into our ecosystem instance that we already have up and running? So then we just ask ourselves, is it structured or is it like not? And either way, that's a relatively trivial thing to integrate into the ecosystem instance. We'll use a presser connector if it is structured, and then we'll import it and transform it to NoSQL. If it is already NoSQL, then that's as simple as getting our hands on the files, ingesting them into Mongo collections and Mongo databases. Once we've moved on, this can all take place, as Jay touched on earlier.
Yes, maybe it's worth mentioning that it doesn't always have to be Mongo.
Oh, yeah, sorry.
So Cassandra,
any NoSQL, So, well, that's definitely worth mentioning. And then, of course, all of this can happen code-free, just in the workbench as well. So now will maybe be a good time to backtrack to kind of the other possible reality in which we don't necessarily have sufficient data to deal with our problems. So then there's going to be a few different options, and then it's going to come down to model choice, which we're going to run into in a moment. But essentially, you will want to define an offer matrix for use later on with those dynamic models, or you'll just use what data you have and you'll have to ingest it. Either way, you'll maybe have to create a custom feature store, like a synthetic custom feature store that you're going to use with a bunch of product data that you do have if you don't have the given customer data, but you still want to approach this problem in another way, maybe from the product recommendation aspect as opposed to the customer feature prediction aspect. There's many different ways it could go. So then there's, of course, like many different phases still in this data engineering or feature engineering section. You'll employ the appropriate enrichment options and clean your data. You'll engineer the features required according to the plan you've outlined beforehand. You'll perform some EDA, inspecting the data on the workbench or in Python, and define what features you're going to need. And you'll use the available tools that are in the workbench or in Python to perform those transformations onto your data. And yeah, you'll write the appropriate pipelines, etc., and run perhaps some algorithms. So for example, for the spend personality use case, it'll be at this phase that you'll run the spend personality algorithm over your data with some defined specific fields to enrich the personality features that you're going to use in the prediction problem. So those are processes that'll take place here depending on the class of problem and how you want to solve it. Here we also have the creation of that offer matrix we were talking about earlier for use with a dynamic model. Once you've gone through all those processes, hopefully you're ready for either your pre-training, your batch static models, or you're ready to configure your dynamic online learning models that you may want to use instead. Jay, is there anything you want to add to our data discussion?
I think when we get to the track of deciding what your development environment looks like, we might get to the deep data. In this context could mean data that is used in a live setting like a vector store. So you might take emails, chats, documentation, and company documents needed for extraction where a generative model is going to do work on it. Data could also mean structured data that has got to do with historical evidence that you have collected that you know is reliable about interactions or transactions that have taken place or whatever the scenario might be. And you also in some situations have a decision point around the dynamic model. When you have no data accessible, you've got a brand new product you're launching in a brand new market, you don't have any understanding necessarily of how it's going to behave yet. So you want the data to be generated dynamically while you use the inference, but you still want it to make decisions. So you want algorithms to decide what needs to happen. For dynamic, static, and generative models, you go through the same cycle. You have to decide what kind of data you would use or not use. And I think maybe just one last point is that the offer matrix, I don't know, there's probably not a good name for it because in our world, it's called the product catalog, the offer catalog, the message catalog, or the nudge catalog, whatever you want to use that's going to connect the messaging that you're going to push out to the world with, let's say, a human or an action, and you want to drive a prediction on the back of that for these different worlds together. That capability, in many cases, can be generated as well. So it doesn't necessarily have to be something that you provide. But if you're going to sell a product to a market and you want to predict a nudge or a message or a sequence, then you're going to need a product catalog. You can't, so that means there's some dependencies depending on what your use case is as to what you need to do. If you're going to sell it to a customer that is known, you need to know that that known customer's data that you're collecting is reliable. If I know that I'm selling it to people that are signing up as brand new customers, how much do I need to get from you before the model scores? So they all have different.
Yeah, 100%. Cool. Now let's move on to that. So this splits into 3 tracks that Jay was talking about. So in regards to the different solutions, what tools do you want to use and what do you want to build, right? So that's going to largely determine the ordering in which you train or set up your models. Though in reality, you're going to be using an ensemble of solutions coupled together to solve some problem. So here we have just this generic models part that is going to take us to the decision of the process of setting up a static model, how that's different to the process of setting up a dynamic one or a generative one, as Jay mentioned. And then we have this extra node here to represent our ecogentic framework. So we didn't even touch on that when we were talking about our ecosystem of technologies above, but this is essentially ecosystem's journey management system. It's a tool to develop customer chat journeys and integrate them with other models, integrate them with generative models for a chat backend so that it can be a linguistically pleasing experience for the customer, as well as integrating it with your dynamic or static models so you can still provide intelligence and prediction to that journey. So that's our framework. However, we have integrated in the past using other journey management frameworks, including what Microsoft's name slips my mind. What are they called? Microsoft's, I want to say Gemini, but that's Google. Anyways, So it's not that we force you to necessarily only use the ecogentic framework, but it is a tool that we offer. And then, the algorithms is also specified here because depending on the class of problem, you may need to go back and rerun those algorithms that we were discussing up here in the data phase to make sure that you have access to all the features that you're going to need.
Azure, Microsoft is called Azure pipelines. Well, Azure pipelines is essentially a pipeline approach. Or if you use an open source product or a pipelining tool, because everything in our world is headless and accessible through an API, it makes no difference to us. Any pipelining tool can call a server to get a job done, and it returns a message, a response, and some kind of fixing capability. That means almost all pipelines have a handful of things in common. They mostly design around directed graphs. So a directed graph means that it goes from state 1 to state 2 to state 3. If it gets to the next state and something has failed, do you want it to fail terminally or do you want it to recover? So they all have these common traits, and we've integrated with all kinds of pipelines. So it doesn't really matter to us.
Yeah. Okay, perfect. So then just to touch on some of the differences between setting up these approaches, we've already spoken extensively about the training of the static models when we spoke about H2O above, but you can do that completely code-free in the workbench just by filling in some of those like abstracted hyperparameters and then running that training job, and the server is going to handle all the execution in the back end, and it's going to return the results in a pretty way that you can then manage and then retrain, etc., until you're happy. Or you can, as we discussed before, you can do it in-house in your own environment and we'll happily just import it. For the dynamic situation, that is slightly different because you're going to use our configuration journey. You're going to decide on the algorithm that you're going to want to use for this class of this dynamic problem. And then you're also going to decide whether or not you want to whether you're going to warm or cold start it. So you can find sometimes yourself in an odd position between where you don't have a sufficient volume of data to train a reliable static model, but it may be useful in just warm starting a dynamic model that is still going to access that data on the fly and learn online. So then you can also configure that during the setup of your model. The generative workflow is a little more diverse. Maybe Jay wants to speak on the non-ecogentic one. Here, we've mainly just outlined the building of the agent in a graph-based way, which is how it takes place using the ecogentic framework. Setting up the generative backend and plugging in that is slightly different.
The backend sits in our prediction server. The way to access it from any external environment through its API supports the OpenAI API invocations specification. So that means that if you have an existing chatbot or an existing agent framework or an existing agent journey environment or an existing AI workflow that relies on OpenAI or Anthropic or Llama or any one of those tools, they all now support exactly the same standard when it comes to the invocation API. So what does that mean? If you send in a prompt, the prompt is a model and an array of messages that you keep in your memory, and you can call our server. If you set the backend to be ecogentic, it means you can control the conversation with our guardrail environment. For every agentic journey, you have to have a guardrail framework. You need to know on one end what is accurate and precise, all the way through to the other end what is linguistically useful. If I need to obtain Bodhi's bank balance and Jay's number of transactions or whatever that might be, and I need a highly accurate answer, you cannot leave a generative model to do that for you. The agent will have a tool, and the tool attached to the agent will go and fetch the data for you and then morph it into your language. So if you say to it, please compare Jay and Bodhi's transactions and tell me which customer I can sell a loan to, you want to make sure that by the time it generates the recommendation, the data that used is reliable, and by the time it gives you an answer, it could describe the loan in 5 different ways. But if the loan is called loan ABC, that my company does not sell, then I'm going to tell you to buy something that doesn't exist. So that means I need to make that accurate and precise. So that means that what we call fact injection is what the ecogentic framework assists. But the way that you call it is exactly the same way that you would call a generic chat engine. You add this middle layer between your chat interface and what the generative world allows you to access. So we connect the OpenAI and the tools behind the scenes, but there's this layer in the middle that deals with all the fact injection capabilities, the vector store capabilities, and all of those environments that you need to have in place. We support things like LangChain and LangGraph and the like. So that means if you already have those implemented, you can bolt it into our environment as a worker, but you still need that journey to be vetted, controlled, and approved, especially if it's in a regulated enterprise.
Perfect. Thank you. Yeah. So that's the role that fact injection plays. And then, of course, the complete integratability of the different generative options. We're almost low on time, so we must decide what is going to be more important to cover.
If I can step in here for a second and just say that I think we should do what we did with the architecture session and run a workflow 102 next week. Obviously, it depends on availability. So if we can just sort of finish up a narrative for today, however long that takes, we can go a little over time, and then we will go into the further swim lanes in next week's session.
Perfect.
What we can also then do next week, Jess, is we'll check with Ramsey, or maybe one or two of the other team members, that we show people what an Airflow workflow sequence looks like, or we take a cloud kind of pipeline and we show what a cloud pipeline, when it accesses this capability, what it looks like. Because remember that we are an adjacency to your existing AI stack. So we don't replace your cloud, you don't replace the entire environment, but you can do many cases end to end in our world. So that means that we just, in a separate session, can maybe then show, or maybe we can make the next session far more technical for those people who want to get into the coding and the detail. We can show some of that.
Absolutely, we'll make it one of the hybrid ones.
I'm excited about that one. So let's maybe just wrap up getting to the deployment phase. And as Jess says, we'll leave the delineation of environments in terms of the actual life cycle of a use case for a little bit later. But yeah, so how the structure of the platform works is that once we have configured or trained our models as we have chosen, then we're going to need to bind it to what's called the deployment. And deployment is essentially linking this model that we've configured to a specific configuration file that can be handed to the ecosystem runtime. The runtime will execute according to the configuration file, score against the model, and return that way. So that's what we mean in terms of the configuration of the deployment. Is you're going to outline what models are responsible, and you're going to also outline some versioning and some descriptive data, as well as connections to the relevant databases that it may need to query from, etc., as well as this is where you'll set up your offer matrix and on and on.
Maybe what we just could maybe do is link some of this conversation to Architecture 102, where we discussed, are the pipelines run in OpenShift, Kubernetes, or some architectural environment? By the time you have spun up your cluster in dev, test, or production, you have permanently accessible services that can scale based on demand. So that doesn't mean that you have to allocate an enormous amount of resources that's going to be used, that's going to sit there without being used. And that's what the permanently in production really means. So when you create a configuration for deployment, by the time it gets approved in test and it goes into production, it'll be done automatically. There'll be a Python pipeline that runs once it's been approved by your production lead or by some test that has been done. The test could be on scoring, the test could be on accuracy, the test could be that if it's a generative model, language viability, you would have a common set of prompts. By the time it goes to production, you have an understanding of how reliable it's going to be, the target audience that's going to be interacting with it. And that means production alleviates an enormous amount of problems that normally come with pipelining and the complexity of pushing things into production and having long cycles of delivering cases. So we're trying to compact the time of the case into production enormously. We're trying to make it very short so that the company that use us will be able to, and this is kind of a vision, spend an hour session discussing a new use case, configure it, get it into production, and run a test in the afternoon because they've in the morning managed to configure the entire thing. So that's kind of the vision, so that your prediction capabilities just go through the roof. You you can be exponentially more productive by allowing it to be permanently production.
Yeah, 100%. So then, yeah, just to add on to what Jay's saying, once the prediction is quote unquote in production, once your whatever pipeline, if you're in a production context or maybe just manually in the dev environment, once that runtime has received the configuration, then you can just call that runtimes. Again, we're talking about the open API specs. You can normally call this invocations endpoint for that runtime URL to score against whatever model that is associated with the configuration that you've handled it. And then again, we see the machine readability of exposing the runtimes via these APIs, because now you can integrate these predictions into any sort of channels where you may want to pass it to a customer-facing channel. You can literally just call this API endpoint from there in like 5 lines of code. So that's part of the streamlinedness of compacting that time to production. And then, yeah, so then there's also testing API functionality that sits in the workbench, as well as you can use curl, whatever, if you're working in Python, to make sure that the models that you've pushed to the runtime are actually behaving correctly. And then once you're getting the correct structured API response that you may have edited using your custom PostgreSQL logic, you'll want to run the simulation. This can happen easily in Python or in the workbench, in which kind of you test the behavior of this model under load and over a huge amount of data points in terms of invocations or responses. You can manage and evaluate the model performance that way and quickly iterate. So then, yeah, you will simply, if you're seeing performance that you're not expecting, you iterate back to maybe retrain the model, redefine the hyperparameters, adjust some of the parameters of the dynamic model, etc. And then you can run back through to that simulation point and these testing points until you're happy, and then you can pass it forward to whatever's the next environment or destination for the use case.
That's great. I think maybe we should wrap it up there for today. These journeys can be customizable depending on what pre-work you've done, what templates you have available, what environment you have configured. And I think maybe in the follow-up session, we can get into a lot more detail of what those look like.
Absolutely.
I would love that.
So Jay, you've summed it up very well. I'm going to sign off and say goodbye, and I hope you have a great rest of your day. We will see you next week. Keep an eye on our website events page for the link to the invite to next week's session. Otherwise, there's plenty of information in the chat, links and whatnots. And for those that have access to the Canvas now, you will continue to have access, and we'll give access again next week.
Thank you so much.